We are going to be adding practice problems into your foldable, so hopefully you save some room on each page to work these out. So starting with rectangle and square, this is something you should already be pretty familiar with. Area for a rectangle or a square is base times height, but now we're looking at some kind of irregular looking shapes. So there's two ways that we can solve a problem like this. One is the divide and conquer, where you kind of would split it up into multiple squares or rectangles, or you can use the add and delete method, which is my preference, so that's how I'm going to work this one out. So I'm going to draw imaginary blocks on these two corners, and essentially what I've done here is created one large rectangle. So if I were to find the entire width of the base, it would be this 8 across the top and this 4 right here. So that's a total of 12. And the total height would be this 5 here and then this other 3. So we're looking at 12 by 8. So that's the size of my large rectangle. So that would be the add, and then the delete would be I need to subtract these two little rectangles from the corners. So I have a 3 by 2 and a 4 by 3. So what that's going to look like is an 8 by 12 rectangle minus my 3 by 2 and minus my 3 by 4. And so that gives me an area of 78. Okay. So again, rectangle, square should be pretty straightforward. You've been doing that since elementary school. Next we have parallelogram. And in this particular parallelogram, I'm told 2 of the sides and that this angle right here in the corner is 60 degrees. So the area for a parallelogram is also base times height. And here I'm given my base, but my height is actually going to be this length right here, this perpendicular length. So this actually makes a right triangle, and because this is 60, I know my other angle is 30, so this is actually a 30, 60, 90 right triangle. So I can use what I know about special rights to find the height. So here the hypotenuse of my right triangle is 6, which means my side opposite the 30-degree angle would be half that. So this segment right here is 3. And my side opposite the 60-degree angle would be 3 on the square root of 3. So again, my whole base is 14. We just solved for the height. So 14 times 3 on the square root of 3. Remember, when we're multiplying radicals, I just multiply what's outside together and what's inside together. I don't have a radical on the 14, so I'm just going to multiply the 14 and the 3. And we're going to get 42 square root of 3. Next is triangle. And the area for our triangle is 1/2 base times height. And here on this triangle, again, I'm given my base, but I need to find my height. So what I'm going to do is project or extend this triangle to make a right angle. So here I have one large right triangle, and I know that this angle is 30 degrees, which means that this angle here would be 60, and I again have, if it'll focus, a special right triangle. And again, I'm looking for my height here. I want to find this vertical length. So one of the values we're given is the hypotenuse of our right triangle, and the side opposite the 30-degree angle would be half of that. So this vertical length here, which is our height, is 8. So I can now solve for the area of my triangle. And remember, I'm just looking for this one. So my base is 7. So 1/2 7 times 8 gives us 1/2 56, which is 28. Next, we are moving on to trapezoid. And remember, the formula for area of a trapezoid is our median times the height. And the median is the average of our two base lengths. So first, let's solve for the median of this trapezoid. I know one of my bases is 9 and the other base is 17. So my median is going to be 1/2 9 plus 17, or the average value. So that would be 1/2 times 26, which is 13. Now the other value that I need is my height, and that's again going to be this perpendicular length right here. So I need to solve for it. Well, I've made a right triangle here, and I know that this is a rectangle, so this length is 9, and the whole base is 17, so this piece left over would be 8. Now I can use my Pythagorean triples to find this height without calculating Pythagorean theorem. So this is actually an 8, 6, or 6, 8, 10 triangle, which is a variation of the 3, 4, 5 family. So my height is 6, and now I'm ready to solve for area. So our area is our median, which we found to be 13, times our height, which is 6, and so our area is 78. Next, we are on to kite, and for kite, our area is 1/2 diagonal 1 times diagonal 2. And so for this particular problem, I already have my kite drawn. I'm told that BD is 10 and that angle BAD is 90 degrees. So I'm going to label that. And then remember, our diagonals bisect each other in a kite and are perpendicular. So that would mean that B to this middle point is 5 and D to this middle point is 5 because they total to 10. So I know BD, that's my one diagonal, but I need to find AC, my other diagonal, in order to solve for the area. So one thing I have here with this triangle, right triangle on the top, is I know I've had a hypotenuse of 13 and a side of 5, and this is actually one of my triples, so I know that this length here is 12, because 5, 12, 13 is one of our families. Now I just need to find this other segment so that I can find the total length of the diagonal. Now, because these two segments are congruent, and this is a right triangle, I have an isosceles right triangle, which is also a 45, 45, 90 right triangle. Okay, so triangle BAD is a 45, 45, 90. Which means that BA and this middle point and DA and this middle point, which also make right triangles, are also 45, 45, 90. So the length of B to the center and D to the center is the same length as A to the center. So this is also going to be 5, because these are also isosceles right triangles. So that means that the total length of AC is 17. So I'm ready to calculate my area, and that's going to be 1/2 diagonal 1 times diagonal 2, and my area is 85. Next we have rhombus, which has the same formula as our kite, 1/2 diagonal 1 times diagonal 2. Just a second to focus, come on. There we go. So here I have my rhombus, and I know one side is 25, and the whole length of this diagonal is 14. So what I'm going to do is draw my other diagonal, and remember, in a rhombus, our diagonals are perpendicular and they bisect each other. So if this whole length was 14, my other diagonal would split it into 7 and 7. So what I have here is a right triangle with a hypotenuse of 25 and a side of 7, which means that this other side would be 24, because 7, 24, 25 is one of my families. So this other half is also 24. So my first diagonal was 14, and our second diagonal is 48. So our area is going to be 1/2 14 times 48, which is 336. All right, we're more than halfway done. Now on to regular polygons, and what I have drawn here is a regular hexagon. Now remember, regular polygon means all of our sides are congruent and all of our interior angles are congruent. So what I'm given here, This value right here is the radius, and what I need to find is the apothem, and the apothem is perpendicular from the center to one of our edges. Now, because this is a regular hexagon, all of my sides are going to be 12. So this whole length down here is 12. So the perpendicular bisector would divide this in half, and so this length is 6. So I'm going to have to use Pythagorean theorem to find my apothem. So let's call this value x. That's what I'm looking for. So x squared plus 6 squared is equal to my hypotenuse squared. And so we find that x squared is equal to 108. So I square root both sides. I need to simplify. The square root of 108 is equivalent to 36 times 3. So I can pull out the square root of 36, which is 6, and my square root of 3 stays inside. So that is x. So my apothem is 6 on the square root of 3. So my formula for area is 1/2 apothem times perimeter. And I find the perimeter by adding up all the sides, or I could just multiply 12 by 6, and my perimeter is going to be 72. So to solve for area, I'm going to have 1/2 my apothem times the perimeter. And remember, when we're multiplying with radicals, we multiply our constants together. So that's going to be 1/2 432 on the square root of 3. And then when I divide by 2, I get 216 on the square root of 3. Okay, and now we're moving on to circles. So I am going to be finding the area and the circumference of 3 circles. The first one is with a radius of 1, and that one's super easy. So our area is going to be pi times 1 squared, or just pi. So when we're working with these circles and our segment and sector next, we are going to be leaving things in terms of pi, which means I just leave pi there. Same thing as I would do if I had a variable. We're not going to actually use a numeric value for pi. And our circumference would be 2 pi times 1, which is 2 pi. Again, I'm leaving it in terms of pi. Next, if our radius was 8, our area would be pi times 8 squared. 8 squared is 64, so 64 pi. Circumference is 2 pi times 8. 2 times 8 is 16. So 16 pi is my circumference. And lastly, if our radius was 15, our area is going to be pi times 15 squared. 15 squared is 225. And we're leaving it in terms of pi. And our circumference is 2 pi times 15. 2 times 15 is 30. All right, and I will be working the segment and sector problems on a next video.